Hi, everybody. Welcome back to Awkward Science, Episode 3. Today, we're going to examine circuits by looking at the following question. Will a fuse work successfully if it is connected in parallel with the device it is supposed to protect? Well, in order to examine this question properly, we really need to break it down. First, let's explore what is a fuse and how does it protect devices? So, a fuse can be found in pretty much any complex device that draws power from some source, whether it's a direct outlet source or from some kind of battery, like your car has a battery in it that powers the electronic devices inside. It has a bunch of these small fuses inside, and their job is to protect the electronics like the stereo or the air conditioning or the charging outlets, whatever it is that is running off electricity inside of your car. If you look at the diagram or the picture of the little fuse there, you'll notice that there's a small kind of wire running through, a little piece of metal. This piece of metal is the part of the fuse that does the job. What it's designed to do is to either melt or break if too much current is flowing through the fuse. When that happens, if that breaks, then the current will no longer go through the circuit, and it'll stop an overload from getting to the devices in your car or wherever and damaging those devices. Now, like I said, you can find these in all sorts of things. Another good example place that we find this is inside of our holiday lights. You don't find it inside of the lights themselves usually, but often you'll find it in the little part that goes into the electrical outlet. It'll have a little part that slides open, and that's where you'll find the fuse. And if you look at that little fuse, you'll see that there is a piece of metal, a metal strip in it. And if the fuse burns out, you'll notice that it's got this black smudge on the glass surrounding it. That's how you know that it has burnt out. Well, let's go back in time because holiday lights are also a great example of circuits because they are pretty simple circuits. Back in olden days, if there was an overload to your circuit, your whole string of lights might go out. Now, that wouldn't be because of a fuse, because the fuse will turn off your whole series of lights, and that's great. It prevents damage from happening to the filaments inside of each light bulb. But what used to happen with strings of lights is that they were wired in series, meaning that if one filament in one of the bulbs, any one of the, 100 bulbs that are in a series of holiday lights, if one of them burned out or if the bulb was too loose and the electricity couldn't get through, then it cut off power to the entire circuit. So back in olden times, your lights would often go out and you'd have to go and you'd have to check every single light in the strand to see which one was burnt out, had a loose filament, or if the light bulb had just gotten loose in the socket. And then once you found it, if it was only one, then the whole string would come back on. Now, fast forward to today, strings of holiday lights are made much better. So you can have one bulb go out in the string, and the rest of the string will keep on staying lit without any problem. And so this kind of takes us to the concept of series versus parallel circuitry, which is the second part of the question that we're looking at, because it asks, well, if a fuse is connected in parallel, work in a circuit? Well, we have to know the difference between series and parallel. So let's take a look at series circuits versus parallel circuits. The circuit on the left is wired in series. So that means that there's only one path for the electricity to follow. It goes from the power source. You can see it goes into the first bulb, the second bulb, and then back to the power source. There's a switch in this circuit that can cut off the flow of electricity. A switch acts kind of like a fuse, but we'll get to that in a moment. The circuit on the right is in parallel. So what you see there is that there are two paths the electricity can follow. It can go through one bulb or the other, or both. And in the instance like now, when the wire is broken to one, the electricity will simply follow the path of least resistance and continue through the circuit any way that it still can. Now, let's take a look at these two circuits and imagine that the second bulb on the circuit on the left and the top bulb on the circuit on the right were the devices that we wanted to protect with a fuse. Then let's take that other light bulb and let's replace it with a fuse. So let's think about this for a moment. If we were to replace those second bulbs with fuses, would the fuse be able to do its job of protecting that light bulb? Let's have a nice awkward silence while you think about that for a moment. That's right. A fuse can only protect a device if they're wired in series. In the circuit that was wired in parallel, the electricity was able to just flow around the broken fuse. So it wasn't doing its job of protecting the device. In a series circuit, like the one you see here, the fuse is a gatekeeper. The electricity cannot flow past the fuse. If the fuse breaks, the circuit is broken and the device is preserved until you fix the fuse and check the whatever was causing the big rush of current. Now, most circuits are not as simple as a simple series. They'll have a series part to them, but they're definitely going to have some part that is a little bit more complicated. So in this diagram that you're looking at, this would be a little bit more like your house or some more complicated device. You have a power supply at the bottom. You have a fuse that is right next to the power supply. So it is wired, the fuse is wired in series with the power supply. This power supply is going to provide electricity to all these different loads. In this case, it's a toaster, a lamp, a heater. But they are wired in parallel to each other, meaning that whether the toaster is on or off doesn't affect the lamp or the heater. You can have any one of those things working. If one breaks, the others will continue to work just fine. And a fuse in this diagram is the same thing as like the way a circuit breaker works in your house. Instead of a melting piece of metal, a circuit breaker just is a switch that turns on or off if there's an overload in the circuit. Well, thank you for watching this episode. I really hope that this helped you understand circuits a little bit better. Please use this code to answer the section review questions. Until next time, this is Awkward. See you later.